Okay, so on the next page, we've got another one here. It looks a little bit different because it's got three different factors, and that means that they're just all going to go through the x-axis. Nothing's going to be repeated. So if you're feeling pretty confident, go ahead and stop the video now and try to work this one out on your own and restart the video and just kind of check your work, see how you did. Okay, so once again, the first thing I'm going to do is look at this lead coefficient up here. It is positive, and it's going to give me yet another up coaster pattern because it's cubic. And I know it's cubic because I have three x's, and I have solutions of -2, +1, and +3. So that means I can graph all three of these. Okay, so I've got an up coaster pattern going all through of those points. Going through all three of those points. All right, now what I need to do is I need a little bit more detail. So I'm going to use, and it is up to you which ones that you use, but I've got so much information here. I'm gonna do -3 and then -1, 0. So these are all kind of like the in between the solution ones. 2, and then 4. Now, if I use those, I should have a really good idea of what it's going to look like. I'm going to pause the video. I'm going to fill out this table. You just have to plug all of these into your calculators, and let's see what we get. Okay, so I've got my table filled out. I went ahead and I graphed the remaining points. This one actually looks a little bit better than the last one, and it absolutely does follow this up coaster pattern. So let me see if I can very carefully, don't put any sharp points or corners in here. It should be smooth. Make sure you have arrows on either end, and that is our graph. Now, is this exactly what the graph looks like? No, but it's pretty darn good. So unless you have Desmos to figure out exactly where it starts and stops and all that good stuff, this is really good. So this next question is a little bit of a mystery. It says the graph of a cubic function crosses the x-axis at -1, 0, and it touches but does not cross the axis at -10, 0. So let's draw a picture of what that would look like. So here's approximately -1, 0, and it goes through that one, right? Because it says it crosses the x-axis. And then way over here at -10, it says it touches it. So it's either going to go something like this, so it'll touch and then go through, or it could touch and go through. So it could be the orange one or it can be the purple one. So it says, can you determine any solutions of g of x? Yeah, I mean, the solutions are going to be -1 and -10, obviously. And if it touches at -10, that means technically your solutions are going to be -1, -10, and that -10 repeats. Can there be any more solutions? Well, I mean, it says it's cubic, right? Can it have any more than 3 solutions if it's cubic? No. So, and that's the explanation. So if it's cubic, you can only have 3 solutions, and we're done. Okay, so let's talk about turning points. You've already studied turning points. We call them like a relative maximum or relative minimum. Your book specifically uses the word local instead of relative. So it's kind of like the little hill or a valley. So the reason why they call it a turning point is that it is increasing here. And then all of a sudden, exactly right here at this point, they decided to go ahead and change its mind and direction, and then it starts to decrease. Same thing here, it changes its mind, starts to increase again. So a turning point is basically turning from increasing to decreasing or decreasing to increasing. And just remember that your turning points are known as the relative max or the relative min. So if we wanted to go ahead and do this last problem, to tell exactly where the turning points are, your maxes and your mins, you really do need to use technology, specifically Desmos. If it's quadratic, it's really easy to tell. You can just use -b/2a to figure out the vertex. But if it's cubic, you need to graph it. So I'm going to pause it right here, and then I'm going to swap over to Desmos, and let's graph it together. All right, so I've got the parent function in here right now, and I want you to see that the parent function has no turning point. So just because it's cubic doesn't mean it has one. It's kind of got this point right here where it's like, I could change my mind, but it doesn't. Like it's increasing, and then it hits the 0, 0, and then it still continues to increase. So it's got like that roller coaster type shape, but it doesn't have a relative max or a min. So no turning points in this one. If I wanted to graph what was on our notes, we've got x to the third minus x squared plus 6. So if you look at this one, you definitely have some turning points in here. But what this question is specifically wanting you to do is it wants you to identify the x-intercepts. So I have one x-intercept right here. I'm going to click on it. So on our notes, we need to write negative 1.2. Now this is rounded. If you round it, make sure that you understand that if it's rounded, you can't work backwards and find a factor, because the factor would not be x plus 1.2. It would be x plus 1.196, but I have a feeling that this is rounded also. So be really careful with that. So your x-intercept is at negative 1.2 rounded. I have a y-intercept here, which also happens to be a local maximum. That's at 0, 6. And then I have a minimum here at 2, 2. So what I'm going to do is I'm going to copy this. I'm going to paste it over at my notes, and then we will finish that together. Okay, so we're back on our notes, and I'm going to use my highlighter to highlight where this is increasing. So remember, you have to read your graph from the left to the right when determining your intervals of decreasing and increasing values. So I am increasing here. I stop at the turning point, start to decrease, stop again at the second turning point, and increase again. So how are we going to write down our intervals? So interval for, let me just put increasing. You can write it in interval notation. So increasing would be all the way from negative infinity up to 0. Now a lot of people want to put 6. Your intervals are x values. So from the far left is negative infinity up to 0 here. And then from 0 up to 2, you decrease. Once again, you start back increasing at 2, and then you continue on up to positive infinity because it goes forever. So that's how you use interval notation. If you want to use inequalities, increasing is going to be less than 0. So x has to be less than 0, and x has to be greater than 2. So if you look on your x-axis, anything less than 0 over here is increasing, and anything greater than 2 is increasing. And then decreasing would be between 0 and 2. So 0 less than x less than 2. Now you also have to write your x-intercept. So your x-intercept is this. So x-intercept is negative 1.2. The point where it's a local max and min, so max would be 0, 6, and your min would be 2, 2. Now, you may have to write your x-intercept as a coordinate. If so, that would be it. And that is your notes.